Okay, again, hi everybody. Thank you for joining us today. I would like to remind you that this meeting is held under the intellectual property rights policy adopted by the One Ed Tech Consortium, and that you can download a copy of that policy on the website at imsglobal.org/IP. I would ask that anyone in attendance inform me if they are personally aware of any claims under any patent applications or issued patents that would likely be infringed by an implementation of the specification or other work product that is the subject of this meeting. You need not be the inventor of such patent or patent application in order to inform us of its existence, nor will you be held responsible for expressing a belief that turns out to be inaccurate. I'd also make quick mention of the participant agreement, and that one basically says that whatever we do shouldn't be shared outside of the membership without prior consent from One Ed Tech. Okay, so for today's presentation, we're going to be talking about the LTI platform storage, or the cookie solution that the LTI project group has come up with. And we felt that this was a very good time to return to this topic, as those documents have been made available for public consumption. So if this is a problem that you're experiencing and working with partners that may or may not be One Ed Tech members, those documents are now available to everyone to begin use to solve for that issue. So we figured it was an important time to get back in front of the community, give a presentation, and then answer any questions that people may have about the solution. So today, Martin, one of the co-chairs of the LTI project group, will be walking us through a presentation, and then we'll open it up to the community for question and answer with the group. So go ahead, Martin, take it away.
All right. Yes. So as Josh said, my name's Martin. For those who don't know me, I work for Turnitin, and I'm the co-chair of the LTI working group. So today we're just going to talk over. It still has a little bit of a convoluted name. I'd call it the LTI platform storage solution that we have, and basically what it does, what the problem is that we're trying to solve, how it solves it, and we'll kind of go over it in a few different levels and then show some demos of it. And once we have all of that, we can have any Q&A that people might have around it. So when we start, third-party cookies. So third-party cookies is probably something that you might have heard of whilst talking about building web apps or building LTI tools over the past few years. It's becoming more and more prevalent. So basically what a third-party cookie is that if you have a cookie that is set from a frame inside a website that isn't the same frame as the top frame, so that could be anything that is embedded on that website, then it is a third party to the current web page that you're on, and you come under the third-party cookies restrictions of whatever your browser might be. So, there's a whole multitude of things that can be embedded inside iframes, all sorts of embedded content, but a big contributor to that is advertisements. So you go on any website and you have adverts, they're usually embedded inside an iframe. And what those adverts can then do is those adverts can set a cookie and say, hey, Martin was on this site and he was looking at X, I served him this advert. And then when I go to another site and that same advertising provider is embedded on that other site, it goes, oh, I set a cookie. I know that Martin accessed one site over here. He's now accessing this other site over on another page. So that's where we get tracking cookies from. So there's been lots of conversation around tracking cookies about whether they're good or bad, and browsers tend to go down the route of, well, we need to block tracking cookies, which means that we need to stop anything inside an iframe that is a third party to that window from being able to set cookies, maintain state between pages, or know anything about that transition. So that's where we get blocked third-party cookies from. And subsequently, it means that they block it for everything that's in an iframe, which isn't just adverts, that's also LTI tools. So we have to find a solution to that, because LTI uses OpenID Connect, and OpenID Connect requires you to navigate away from the first page that is hit. So you hit the login initiation page, go back to the platform login initiation, and then they do the actual launch with all the LTI data back to the tool, which means that you go from the tool to the platform and back to the tool again, and you need to maintain the state between all of those. And if you don't have cookies, how can you maintain state? So let's have a little look at what the problem is. So this is my little mock-up web browser. So a platform is going to load the tool's third-party login initiation. So this is the first request of the OpenID Connect flow. It's loaded inside an iframe. So the tool is going to say, okay, I need to know that the user has launched inside this frame. So it's going to generate a state and a nonce. And it's going to add those to a cookie, or it might put them in local storage or something like that, so that it can access them later. So it's added them into the cookies. And then the tool is going to redirect that iframe back to the platform and say, all right, I'm done. Now you can launch back into me. So it's going to pass the state and the nonce that it's just set in a cookie back to the platform. And now we're in the platform in that iframe. So the platform is going to receive that login initiation request. It knows the state and the nonce that it's just been told it's got to send back, along with the other initiation values. And then it also gets its login hint and its message hint. So that was the state that the platform has passed down to the tool and back up again. And it goes, okay, well, I'm going to validate those. Well, validating those works fine because it's first-party cookies. It means that the frame here, right, is the same domain. We're on example.platform. We're on example.platform here. So this is a first party. So it has access to cookies. So checks its state, everything's fine. And then it's going to say, right, everything's fine. I'm going to launch into the tool and I'm going to pass it the state and ID token, and the nonce is inside the ID token. So now launching back into the tool, we're back on the tool's URL. This is where we're passing that state and nonce. And the tool goes and has a look in the cookies that it has stored, and that cookie box is empty. Somebody's eaten all the cookies because the browser doesn't like you having access to third-party cookies, so it's empty. So when I try and check it against the state and nonce, obviously they've been blocked and I can't log in that user. So the user gets blocked and they can't log in, they can't continue with their launch. That's a security flaw. We can't say, oh, we'll just let them in anyway, because if you don't, then your launch is potentially vulnerable to certain types of cross-site request forgery attacks and things like that. That's what this is trying to prevent. So the solution. So the solution that we came up with was, if you looked at that previous kind of demonstration of going through an LTI launch, what you'll notice is that that top frame doesn't change, right? Your main window that you're in, we haven't navigated away from that. It's just everything in the iframe that we're going backwards and forwards. So instead, what we're going to do this time is we're going to launch in, and we're launching into the frame, and you can see that this frame doesn't have cookies. Put a little cookie with a cross through it, right? So we don't have access to cookies in this frame, but the platform is going to say, hey, here's your third-party login initiation. And also, I have an LTI storage frame, and the storage frame is parent, right? Which is the parent of this iframe, which is this one, right? This frame in red here. Okay, so we've got a little box here for our storage, and we've just told our tool that there is storage there. So now what the tool is going to do is going to generate its state and its nonce like it did before, but it doesn't have access to cookies. So rather than storing it in the cookie, it's going to do window.parent.postMessage inside JavaScript. So it can say, I'm going to send a message up to my parent. And in that message, it gives the state and the nonce and says, store these for me. So you can see the platform is then storing these values. So the platform will store those values partitioned by the domain of the caller. So in this case, example.tool gets its own little box with its own little bit of storage in memory inside the platform's frame, and that stops this frame or any other tool from being able to access different tools' stored data. Right? You want to limit it to that one tool's domain. And then once the platform stored that, it sends a message back to the tool and says, yes, I've stored this successfully. And now we're ready to redirect back to the platform. So this is much the same as it was before. But this time you can see that this top frame hasn't changed. Right? It's still here. The stored data that we had is still there. And the platform is going to receive state and nonce. It's got its message hint. And then it's got its values that are still stored in browser memory, and they didn't change. So it's going to do its normal validation and launch back into the tool. So here we are, launching into the tool. So once again, you can see that with the launch, we're now adding LTI storage frame, once again, as parent. So we've got a launch, it's got the LTI storage frame, and we're going to do the same that we did when we set the state and nonce into our little bit of storage, and instead we're going to pull it out. So we do another post message and say, I want to get some data. And then it will receive that and it will look up, hey, for this domain, which is example.tool, does it match? Do I have a key that matches that? And if so, what's the value? And then it will return that key and value back to the tool as a post message. So it's worth noting all of this is happening inside the browser, right? There's no calls out to any backend to store this data. It's not being stored server side. It's all just happening in the browser. In essence, what we're doing is we're sort of replacing, not quite one for one, but we're replacing cookies with a bit of storage on the platform's parent frame. So then now the tool can have access to its state and nonce, so it validates it and everything's fine. The user can be logged in. Excellent. So that's kind of like the high level overview of what happens going backwards and forwards. Now we'll just have a look a little bit deeper, actual request wise, of what some of that looks like. So this is how you might see an LTI launch now happening inside an iframe. So we have the browser here represented by these two little people. We have the root frame, so the very top, and then we have the frame that LTI that the LTI tool is being launched in. So you can see here we're coming in, we're doing a launch, we're doing a request to the OIDC login endpoint on the tool. The tool is setting a cookie, doing a redirect back to the platform. So you can see here, this is where if we don't have access to cookies, well, I've just set a cookie here and I've navigated away from that page. And now in this frame on the browser, we've gone from the tool in blue to the platform in orange, and we've just lost any information that we might have had in this request, meaning then when the launch happens that actually redirects to the tool, it's suddenly not got access to the cookie or the data that was set up here. So yeah, so this is the normal LTI flow. So obviously doing the launch, checking your JWKS, validate the ID token, validate the cookie against the state, and display your tool. So how would this same request look, but with the new cookie storage? So this is split into two just because I've packed a little bit more information into it. So we'll look at the first half and then the second half in a second. So the first half here, you can see that we have the launch, the request to the OIDC login is the same, but this time we're including storage target is _parent. And first difference here is rather than doing a 302 redirect, right, we're just going to return a page with some JavaScript on it that is going to attempt to make a call to the platform to store that state and nonce instead, rather than doing it 302, right? So we need to execute a bit of JavaScript before we can move on. So you can see here, this is roughly what you would call. So you can see it's got window.parent.postMessage. So we're sending postMessage from this blue bar here over to this orange bar here. And in that postMessage, we have a subject, which is LTI.putData. So I want to store some data with you. Here is your key. So the key is state 216, whatever, and then the value. So you'll see that we've actually put the value in the key and in the value, which might seem a little bit weird. Why would you repeat that twice? Why wouldn't you just have a key of state and a value of whatever else? Well, it's actually a good practice to do this even when you're setting cookies, because in LTI, you might have a case where your tool appears multiple times on the same page. So if we take like embedding inside a text editor or something like that, you might embed multiple tools into a single page. And if they all open at the same time and two instances of your tool try and set the same key of state as two different states, well, one of them is going to win and one of them's not. And then you'll end up with a race condition, and only one of your tool frames will load correctly. So yeah, by kind of namespacing them like this, it gives you it allows you to not have overlap there and open as many things as you want, all in parallel. So yeah, so that's been passed here. You'll also see there's a message ID. So the message ID, when we get the response later on, matches up with the message ID that we pass. That's kind of handy because we want to know, again, if we're sending multiple messages quickly or doing whatever, we want to make sure that we're getting the correct response back. And then the last thing here is the redirect URL to origin. So this is part of the security around making these requests. Is with window.postMessage, you can put an asterisk there, right? And that will just say wildcard, send this data to anybody. So the problem is that obviously our state is used for security purposes to prevent somebody from being able to maliciously launch me into a tool. Well, if I'm broadcasting what that state is to just whichever frame happens to be there, then anybody can intercept it. So instead, I want to only send that state to a domain that I trust. So in that case, it's the redirect URL origin. So this redirect URL that we are about to redirect back to. So the origin is everything from https://my.platform before the path starts. So that's the origin. So we're basically saying this request is only for that origin. And if it's anything else, it will not send and will stop there. So here, our platform is now storing that in its own local storage or memory or whatever it wants to do. And then it's going to send a response. You'll see that the response is LTI put data, but LTI put data.response. And it repeats the values that it's just set back to the tool, and the same message ID again to say that this is the response to this particular message. And in this case, we're posting back the event to the same place that the post message has just been sent from. So we're just saying, make sure we send this back to the source of the post message and make sure the origin hasn't changed. It's very unlikely that the origin would change, but in theory, you could send a message here and then this change before the response back, meaning you're sending the response to a different page. It's unlikely to happen, but it's something that is better to kind of keep in mind and do anyway. It's not particularly difficult to secure that bit. So here we've just now done the redirect back, and we're going to get on to the second half, which is the auto posting form. So this is our normal LTI launch, right, where we're sending an ID token and the state over to the tool. So again, sending ID token state with an LTI storage target of parent. So now what we're going to do is we're on our back end, we're now just going to validate the ID token, right? We're not going to validate the state yet. We're just validating, is this ID token correct? Yes, excellent. Okay. And we then go back to displaying the tool, and we say the ID token was valid, the authentication was correct on that, but before we allow the user to do anything on the front end, we need to validate that the state is still there. And if the state isn't there, we will log the user out or remove them from the page. It's worth noting that what this is preventing is a malicious user from logging in a different user as the malicious user's account. Right? So it doesn't actually matter greatly that the user gets logged in, as long as they're not able to interact or immediately logged back out. What you don't want to do is just leave the user logged in as the other person's account unknowingly. So yeah, what you see here is it's sending that data back, and now this time we're going to again make a call to window.parent, and we're going to do a get data, just passing the key rather than because we don't have we're not setting the value, we're just getting the key. Different message ID, same redirect URL for the origin. This is something that you'll have in the registration data, so you should be able to access it from your tool at any point. And then the platform's going to look that up and say, do I have a value for this key? Yes, I do. Okay, return the value. And now as the tool, I can say, yes, great, we got that value. The state was stored in the platform. We know now that we've maintained state between those two requests. And if the state wasn't found, we log them out and we display an error or stop them from interacting with the page. And that's basically it. So that's the flow of what we're hoping to add. There are some more depths to this. You'll notice, for instance, the LTI storage target is set to _parent. Well, you might ask, well, why specify _parent if it's always going to be _parent? Well, it could actually be something else. It could be a different subframe of this parent window, right? So the parent window might be an instance of a learning management system, but the redirect URI actually points at the centralized server for that instance. So what you would do is the parent would open an iframe for that centralized instance and say, that is the place where it stores the data. So you can navigate up and you can say window.parent.frames and then point to a specific frame that you want to store the data in, if the parent is different to the redirect URI. I do have a diagram to demonstrate that, but it doesn't fit on a slide because you end up with 3 columns and it gets a little bit longer because you have to kind of navigate through both of them. But yeah, that's kind of the point there. So yeah, a couple of things around security just to note. So as we said, the tool must always specify an origin when sending a post message. The origin must match the origin of the platform's OIDC login initiation URL. It must match exactly the same port, the same domain, same subdomain, the same scheme. So if it's, well, it should always be HTTPS, but that can't be different. So this prevents the tool from accidentally sending sensitive data to the wrong domain. And then the platform provides an LTI storage target to specify the frame that you're sending the message to. And again, it doesn't matter. If I was to try and maliciously set a storage target and point it at my own site, well, that doesn't matter because it would never receive the request because I'm limiting it to that specific domain anyway, that's already pre-registered. So it can't be changed on the fly. So the other one, tool must always validate the origin of the response that comes back from the platform. And again, this is just to prevent somebody from injecting data into the tool. You obviously want to check that the response that you're getting back is from the same place that you just sent the request to. And then platform must always scope the data that is stored by the origin of the sender. So like we showed on that first set of diagrams where we had the little box and the box was just for example.com or example.tool. It must be, a tool must only be able to access the data for that particular domain. And again, it's kind of obvious as to why we would want to do that. You want to prevent cross-site storage access or anything like that. And it's also kind of worth noting that it has to be exact. We're not doing kind of just the top level domain or anything like that. It's the full origin that has to match. There's a point on here that the platform may selectively allow only messages from tools known domains. Most platforms will just accept the message and store the data because the data is not actually interacting with anything. It's just being stored in memory and then returned. There's minimal risk to the platform for storing that data. The only real risk is if a tool decided to store, gigabytes of data or something to slow things down. But it would only be stored in memory at that point. The platform may say, okay, well, only domains of the registered links or something for the tool can store data. That's up to them.
So Martin, we've got a couple of questions in chat. Do you want to take some questions now or hold for a little bit?
I will do this last bullet point and then we'll take some questions because
Okay.
then I will do the demo. So the last one, the capabilities request. So I didn't really mention this in the previous bit, but there is also a capabilities request. So you saw put data and get data. There is a capabilities request, which is what do you support? Because at the moment we have 2 types of message that you can send, technically 3 with capabilities, but we might want to add more down the line. So as a kind of discovery mechanism, you can call your parent and say, what are your capabilities? And the capabilities here, that is the only thing that can be called on a wildcard domain. So because you're always just calling your parent, and the reason that it's always your parent is if for whatever reason you've lost context of the LTI storage target, so you don't know what that is anymore, and you want to find your data, right? You can always just call your parent and say, what are your capabilities? And it will return back and say, I support these particular types of message, and these are the storage targets for the message. So that can be on a wildcard because it's only like it's more like a well-known, like going to a well-known URL or something like that than actually storing or manipulating data. All right, So a couple of questions. Sorry, I haven't had a chance to read through them. Do you have a summary, Josh?
No, but I can prompt you. So Victor asked a question in the a question to clarify, and the question is, what does a tool need to do in order to remember the association between a particular state thing it's stored and the LTI frame in question? I'm guessing that was LTI, not LIT. Like if a parent has 3 iframes with their own launches to the same tool, how does that tool remember which launch goes in which iframe?
Yeah, and that is as we showed here, right? We're using a key of state dash the value, right? So the state is always passed to you when the launch happens. So by looking up the key as state dash whatever the value is, it means that you can differentiate that state between multiple launches happening at the same time. So each state will be unique.
The next question was, Canvas allows a tool to be launched in a separate browser tab. So this would probably all work until the last step, but because there will not be an iframe parent to respond to the post message, do we have a provision for that?
Yes. So in this, just to kind of keep the code that's listed here as short as possible, I put window.parent. It will also work with window.opener. So generally what you would do is you would set some variable to window.parent or window.opener, depending on which one you have access to. And then you can just call post message on that. Generally, if you've been opened in a new window, by being in a new window, you are now the first party. So you will usually have access to cookies. But you're perfectly within your right to use this for instead of cookies entirely, if you wanted to do that. So yes, it would still work if you opened in a new window. And some of the stuff that we'll show in like code examples later on will demonstrate that.
James Smith asks that if LTI storage frame is not included, should tools fall back to cookies?
So generally, if you don't have access to cookies, then you can't fall back to cookies is kind of the point there. Yeah, if LTI storage frame isn't included, you'd want to fall back to cookies, but to fall back to cookies, you will often have to open in a new window.
Yeah, and I think the answer to that is yes, the intention of that parameter on the OIDC initiation launch is for the platform to signal that they support this, and if they're not signaling that, it's very unlikely that they support it. So you could load it and just send off the thing to check if they support it, but generally you would go into your mode where you have to break into a new window or something like that if you don't have cookies. So it's meant to signal, and if the signal's not there, it's possible they support it, but unlikely.
Yeah, and that's where you can also call the capabilities. So I believe the way that we're doing it currently is we attempt to set a cookie first and then read it back. And if we can't read back the cookie that we just set, then we will call the capabilities. And if we don't get anything from the capabilities, we will open a new window. So
Adrian Rock asks, on an LTI launch, could you redirect and get state and nonce before you log the user in?
So yes, on so one way that you can do this, and I've done this in a bit of kind of like demo code that I wrote, which is rather than doing the validation of the ID token here, instead you make this a little bit more of a dumb endpoint that just loads your front end and passes the ID token into your front end. That way, now your front end can do the state and nonce check first, and then call back out to your back end and say, here's my ID token, give me a session or whatever your internal interpretation of that is. So that way you're doing that check first. Again, that kind of plays better into being a single page app than if you're trying to adapt something that isn't currently a single page app. But yes, it is possible to do it that way as well.
Dominic Meglio, and I apologize if I'm mispronouncing anybody's name, asks, has any consideration been given for when the OIDC might be on a separate subdomain? In their scenario, the LMS OIDC is handled by a microservice that runs on a different subdomain than the iPhone parent, as the URL in the browser could be a custom subdomain or even a domain associated with the school district. It works with cookies, but maybe this breaks it.
So, funnily enough, that is exactly what Turnitin has to do. Yeah, a good example of this is actually like Turnitin and Blackboard. So Blackboard have an implementation of this. The instances of Blackboard are on their own domain. So I might have Turnitin or blackboard.turnitin.com, right, as my hosted version of Blackboard. And then for us at Turnitin, we actually have LTI.turnitin.com is where the login initiation goes to, and then the launch goes to API.turnitin.com. So now, in this bit here, this is now a different domain to this one. So the way that we handle that is internally, when you open this page, we then open a frame to the specific page, a specific page on LTI.turnitin.com. So it matches the domain here, and then we call our own frame and we just say, here's a state, is it valid? And it does the validation inside that little mini frame and responds back and says, yes, it's valid, or no, it's not. It's worth noting there, just from if you do have to go down that route, don't go down the route of opening a subframe and then adding code to say, ask subframe to go and fetch this for me, because otherwise somebody else could embed that subframe and then just ask it to fetch the state out of it. So generally what you want to do is you want to embed that subframe and then ask it a question instead and say, is this state valid? And get it to do the checking inside that frame and then return a yes or no.
And an important note on that use case, the average use case for most tools is kind of the straightforward route that Martin showed on this, but we did make sure that the more complicated ones with multiple domains and popping in between different apps and stuff like that was possible with this, but it does take a little bit more work on the tool side to make sure all that works out. But we're lucky that, Martin's use cases cover all those. So we had some good examples of doing that initially. So, but definitely the normal use case is much simpler than those complicated ones, but those complicated ones are possible if you do the work.
Yeah, we had literally the most complicated use cases between the working group members. So we had to solve all of the really complicated ones up front. For most people, they should be able to stick with this workflow and it will work fine. There are more examples in the spec itself of some slightly more complex.
And they asked a follow-up clarification. They just want to make sure that you're using a named frame instead of an underscore parent frame.
Yes. Yeah. So from the platform's point of view, the platform would open a named frame, and then that way you can call window.parent from the tool. You say window.parent.frames, whatever the name frame is, and send a message to that instead. And again, these use cases are explained in the spec doc, so that should hopefully cover everything. I'll carry on and do the demo first. We'll probably have a little bit of time for questions at the end. So let me.
Most of everything that's going on in chat now is platform specific questions that kind of people are answering for their.
Okay.
But if I see something else that needs to get asked, I'll bring it up at the end.
All right, cool. So I'm gonna, for the sake of this, I'm demoing this in two different environments. I'm going to demo it in Blackboard and demoing it in D2L. It's worth noting, so that I can show the debug logging on this. This is running off my local machine. So apologies that it will be a little bit slow. So this is just, I'm actually running in Edge at the moment, right? I have no cookies mode. So this is disabled third-party cookies. And I'm just going to launch into an assignment that I've created for Turnitin. So you'll notice when this launches, don't worry about the red bar. I'll explain that in a second. So this is some debugging. The code for this is available as well. I'll share that at the end. So you can see, there we go. We've got no cookies, but you saw that we launched into Turnitin, went back to Blackboard, and then now we're back at Turnitin again. And we can see the requests that happened. We had a request that was sent from Turnitin, sorry, which was sent from here, right? So this is LTI.local, this is my local machine, and it was sent to turnitintest.blackboard.com. This was the payload. So in this case, we're doing the capabilities. So we're saying, what are you capable of? And the response from Blackboard is, I'm capable of giving you the capabilities, which is good, as well as getting the data and putting data. And this is, like we're talking about the named frames. So in Blackboard's case, they have LTI storage frame, right? So rather than going to parent, we go to parent.frames LTI storage frame. And that's where we need to send any other requests to. So then if we look at the put data, so this put data, you can see that the target here is LTI storage frame rather than parent, because it's on developer.blackboard.com, but here we're on turnitintest.blackboard.com. Right, that developer.blackboard.com is where their redirect URI lives, right, and where it points back to, because that's their centralized server. So, yeah, put request, this was our state. You see that it's namespace, so that's the value as well with the message ID. And then the response has the same message ID in the response, and it's just returning it back to say it was stored. So just to explain the red bar here, you'll notice that the subject in here, which is the type of message that we're sending, in this case says org.imsglobal.lti.putData. Well, as soon as IMS Global is no longer called IMS Global, it is now called OneEdTech. And this spec hasn't been released yet. We thought that we should remove that, but as you can see from Blackboard's capabilities, they currently expect that the old style URL, the old style subject. So what we actually are doing here is we're sending both the old one and the new one, and just saying whichever one we get back, we'll take that. And because it's a front end call, right? You're only calling from one frame to another, and if you do them in promises, you can basically do them both in parallel and it not slow down. You don't have to like try one and wait for it or anything like that. So,
these are the minor pains of early adopters. We hope to iron out things like, naming things correctly. So hopefully most of you won't have to do these kinds of things because of the folks doing it now. These there will probably be a few more iterations like this as this gets broadened, where some things might get slightly renamed as we learn from our mistakes on this. But this is a good example of dealing with those transitionary mismatches.
Yeah.
Good job, Martin.
Yeah, and what's nice is that, as you'll see later on, if you want the solution that I did for this, the code is available for anybody to take a look at, and user they want to. So here we can see, so this was the login initiation. This is the actual launch. So this time, again, we do a capabilities request. But after we've done capabilities, we're then having a look and go in get data, have a look at our state, what was returned. Oh, okay, it was the same thing. So you can see we've now got that key that we looked up and the value. So we know, yes, the state was found. And that was why you logged in. If the state hadn't been found, it would have blocked you. So we'll do the same thing here in D2L, or Brightspace, sorry. Let's get the product correct. So you'll see that differently to Blackboard, Brightspace is using the up-to-date version of the subject. So it's the other way around on this, and the one that succeeded and the one that failed. But it's the same story of here's my capabilities. I fetched them, did the request to put data, responded with that, and then did the LTI launch, and again got the capabilities and returned. And it's also worth noting here, so there is no frame specified, so parent is assumed in this case, because the registration on this is done to this specific instance of D2L, not to the centralized version of it. So yeah, that's the demos. So I have one last slide, and then we can, well, actually two, but one last information slide. So a couple of gotchas, just to kind of think about whilst you're implementing. So one is that recent amendment. We removed org.ims-global off the front of the subject names. So if you're developing off the old spec, might want to refresh the page and look at the new one. Timeouts, it's worth having timeouts. So if you're sending a post request, you've got to remember that the frame that you're sending the post request to isn't obliged to respond to you, and especially if you're sending it to the wrong frame, or the frame, the frame that doesn't exist. If you don't have some kind of timeout for when you send it, you'll just be sitting there indefinitely. So yeah, if you want to be able to show an error to your users, having a timeout there is helpful. We also touched on this one when storing the state and nonce. It's recommended that you include the value as part of the key, and it stops you from having collisions in the case that your tool is launched multiple times in a single page. And then this last one is kind of important, that stored values are scoped by the full origin of the caller. So this means that we are not replacing the functionality of cookies one-to-one, right? Because cookies, I can set a wildcard cookie that is, at turnitin.com and works on all of the subdomains. I have to, in this case, have an exact match of what we're storing and who's pulling it back. Right? If it's a different domain, it won't work. So there are solutions out there for how to make this work in all of those cases, but yeah, that's about it. And then, so the last thing on here is this helpful resources link. So this will send you to the PostMessage library, which I should have really opened. All LTI storage bit for you. So if you want it to, you can kind of replace chunks of your login initiation and just pass it the correct data, and it will, create a state and a nonce for you and return them if you want to do it that way.
Actually, a lot of this lends itself really well to a shared library for both platforms and tools and among the whole community. Yeah. And we're starting that effort. We expect this to keep iterating as other people contribute and work on this. But we really love that, you know, a lot of people just can use the same small, simple JavaScript library to take care of a lot of these problems, so people don't have to implement all these edge cases and nuances themselves. And we hope as everyone starts implementing this, we'll be able to get this central example implementation more robust over time. So thanks for getting that going, Mark.
Yeah, and then the second part of this is you know, just for if you want to just be able to send the post messages. Again, there's abstraction to that. I wouldn't call myself the JavaScript or TypeScript expert, so I'm more than happy for somebody to come along and tell me that there's, you know, neater or more modern ways of doing bits of this. But for the moment, it's just a kind of easier way of abstracting, you know, the calling out, waiting for a response, checking that your messages match, that the response that the request that you sent matches the response that you got back, and, you know, setting event listeners for all of those kind of things. Feel free to grab the code and do with it whatever you like. If you make improvements to it, also feel free to contribute those back. So yeah, that's that. And then the draft specification. So there is also, the draft that is currently up of the specification. And one of the nice things, because this is all front end, we have lots of nice code examples in here as well, because it's all going to be written in JavaScript.
And if there's problems in those or things to tweak, please let us know. You know, I imagine we'll probably be tweaking these examples over time to make sure they're correct. So please let us know if you come across any problems in them.
Yeah, so, you know, we kind of show examples of the fact that you should be looking at the parent or the opener, you know, how you can look for frame. So whether you just look for parent or whether you're looking for a specific named frame on the parent. So yeah, all of that is in here as an example. Probably need to remove the to do.
I don't think we ever fully finished thinking through this one. So, but yeah.
So this is an example of the platform side of things. So, you know, this is how you would respond to events on a platform if you get a request and it says, you know, what are my capabilities? Well, this is how you would be able to respond to those kind of things.
Yes, if that's not public already, Martin, I'll make that public.
Well, I'm not logged in here, so.
He meant the GitHub repo.
The GitHub. Yes, I don't know whether that one is
not. We'll check that right after this call.
Yeah.
I think we're about out of time. I want to make one last note.
Okay. Yeah. Or if there are any questions.
I didn't see anything new in the chat. So
the last thing is, for me anyway, is we tried to build this we're trying to solve the cookie problem and use these browser post messages to do that. But we tried to build this in a way that there's a lot of other exciting, cool things we would like to do with window post messages officially. There's many custom solutions like, you know, resizing iframes and sending messages between them that solve a lot of practical UX problems. And so in the future, we would like to utilize the same infrastructure for solving some of those other problems. And that's kind of why it's built in the way, or, you know, specified in the way it is. There's other things we can solve with this. We're just focused on the cookie thing now. So hopefully in the future, we'll have some really cool stuff.
And on that subject, even what we currently have, you know, I've shown you how you can use that to solve the OpenID Connect state issue, but you can store whatever you want in there. So if you did want to store a value that kind of lasts between requests, you could technically do that as well. It is worth noting you probably shouldn't be storing, you know, like your tool's personal data or anything like that in the platform. You are kind of passing this data up to the platform. But yeah, there's nothing stopping you from storing other bits of information that you might need across requests in that. All right. Any other
Bracken,
questions?
you type faster than I do. I was going to put the same thing. Okay. So I didn't see anything else in the chat. We do have a minute or two left if anybody has a quick question they want to ask. Otherwise, I would like to just thank Martin for giving this presentation and answering all these questions. This was, I think, very helpful for everyone. And if you do have any questions that you didn't think of during this call, you can always reach out to me. I'll put my email in chat. And I'll help to either answer or push them back to the project group and get an answer for you. So thank you again, everyone. I'm going to stop the recording now.